Hey everybody, it's Dr. Jensen with CCJ3701 Research Methods in Criminology. So I wanted to go through the answer key for lab number 4 because I know there were several of you that were kind of stumped on a few questions. You really wanted to get closure on this and see maybe where you got stuck or just verify that you're doing it correctly. And to me, this is an important part of the class to actually go through the labs. But because we did many labs together, there really wasn't much of a need to do this kind of a video. But since I turned you loose kind of on your own with lab 4, I thought we should go back through that one to rework anything you struggled with. So we'll just jump right in. The first part was create your own data in SPSS using these kinds of questions that you would ask 5 people. So this was relatively easy to do if you've put data into Microsoft Excel. SPSS is very similar. And if you did that correctly, you ended up with something like this. Okay, where you had, this is the data view, where you had kind of their phone numbers all listed, exercises. Do you exercise? Yes, no. Most people use a 1 or a 0 for yes, no. How many hours you exercised. Do you play team sports? Again, a yes, no, 0, 1, and then you can actually type in the name of the favorite sport. I would have also accepted you creating a little numbering scheme for these sports if you wanted to. Like tennis is 1, softball is 2, track is 3. You could do that too, but you can even just type them on in. So SPSS will actually take alpha text and numerical text. But this gives you some practice at putting it in, seeing how it's organized. The data view just kind of stacks each individual question in a column with the responses on all the rows. And then, of course, the variable view stacks the variables in rows with descriptions of what's inside the variable next to it. But yeah, something like this or something similar would have done just fine. But I thought it's really important when you're using existing data to appreciate how it got there and learn how to get it in there in the first place. One other thing that's good to know is SPSS can take Excel data, it can take raw text, it can take CSV files, all kinds of different file types. So if you ever need to dump data into SPSS, it's actually pretty easy to do. There's a little wizard that will start to organize it for you. So that was that question. Then the next part of the question was to take on the hypothetical design a data set where you're working for the Department of Education and you're a statistical consultant trying to design it. And I gave you a sample of a survey that was returned and you had to decide what will be a case. Question number 2, what will be a case? A school district. It actually told you so right here. So if you go back into the scenario, it says below is an example of a survey returned from one school district. So that means more surveys are going to come from more school districts. So every row of data answering all these questions is going to relate back to one school district. So that means a case or a set of observations is a school district. That's it. But sometimes that's the tricky part in SPSS is deciding how do I organize all this stuff. So I got a survey back. What constitutes a row? What constitutes a set of observations? Is it, a high school? Is it a person, a teacher? Is it a family? What is it? Well, the only thing that all of these questions could possibly relate to is a school district. So again, if you went back to reread the question, you could actually pick it out right there. So this tells you how you have to organize the data. So one row is going to have all 8 pieces on it, and it's going to relate back to one school district. So every row after that is going to be another school district. So this is kind of a survey for the entire state and all school districts in the state. So this is kind of just thinking, how would I organize data? And the answer was a school district. Okay. The next part of it was how would I organize it and actually give everything names and labels and so forth. So this just kind of was an example of how to do that. The first one was done for you. And as long as you had some kind of a name that related to what it was, a variable label describing it, and then the correct value labels and measurement type, you got full credit for this section. So remember, anything that is a quantity or a number, like number of elementary schools, average spending, the value labels are going to be none on those kinds of variables because we never label numbers. The number is what the response is. So we're not going to say 1 is 1, 2 is 2, 3 is 3. That's kind of a waste of time for a data analyst. So all you need to do is just say none because the number will represent exactly what we need it to. And then over here, what measurement type would it be? You can either use the SPSS word, which is scale, or you can use the statistical word, which is interval. Either would have been acceptable, but this just kind of gives you a sense of, okay, this is going to be numerical data. This is how it's going to be labeled. And then down here at the bottom, you had some kind of topic questions, yes, no style kind of questions. So you would just need to define what yeses and nos are. I would have accepted 1 is yes, 2 is no, or any different number of combinations there. But you do need to indicate it's a string variable or at least a nominal variable. What kind of data is going to be in there? It's going to be, text that represents a category. Okay. So SPSS knows how to treat it. And then district type, you could have done like 1, 2, 3, rural, suburban, urban, 3, 4, 5, and again, just indicating it's string or nominal. So this just gives me a sense you've been paying attention to how SPSS organizes data, how it treats different kinds of texts and labels, which again is important. If you're going to put data in from scratch, this is the kind of stuff you have to think about and organize once you're putting data in. Okay, now we're going into just the basics. So again, on your own, can you find out what variables are and what's in them? This is me not walking you through it. Can you go find this variable, which was called race single category in Add Health, and can you tell me what's in there? So for most people, this is entirely easy. You just have to go click on the value labels and you can find all the different racial groups, including the missing data. Including this one too. There's actually 9, but I don't know if that's went over a page for you or not. Okay. Understanding responses. Now this one was tricky because some people went, what? I don't get this. But she was looking, there was a novice researcher looking at income data using this variable PA55 on row 2580. PA actually refers to a parent survey that was taken and or a parent question that was asked of the kids. And she looks at the data in the data view and sees that, and I even showed you the data view, like she sees some little 10s in here and there's a 10 right there. She's kind of confused, like what? So you could have actually looked in Add Health yourself and seen the same thing. She occasionally sees the number 999. She explains that no one has an income of 999, and her professor tells her, no, the data are fine. Come back and tell me when you can tell me what a 10 actually is. So some people went, does she think 10 is $10? Yes, she actually thinks 10 is $10. So you guys don't make this mistake anymore because you're really comfortable in data, but realize a lot of people who aren't comfortable in SPSS or using data make assumptions about what they see, and they are wrong. So 10 actually equals 10,000. It's a 2-digit income in thousands of dollars. Okay. So this is one thing that, you guys don't do anymore. But yes, some people are like, is she really that stupid? Yes, she's really that stupid. She thinks 10 is $10. So you guys know better than to do this, but realize that you have experience now. You know how to use code books and find variables, and you can kind of piece things together pretty well. So what's the reason for her confusion? Because she's confusing the name or the category of the actual value, with it representing literally what it is without reading the code book. 999 is not $999. It's actually missing data. So, you could say she's not checking the code book. She doesn't understand it's that, this is a 2-digit income in thousands of dollars. Any number of things like that would have helped explain the confusion this person has. But realize people make these mistakes all the time. And you guys are just better than that. So maybe you overthought it. But these things happen. Okay. Making predictions and running bivariate analyses. So this just had you go into some data, and you could have made any prediction you want. I let you do open responses, like how many people do you think would have said how happy they are, completely happy, sort of happy, pretty happy, using the variable on romantic relationships. Like how, in America, how happy do you think everybody is? So this is where you get to make your own predictions, and then you get to jump into data and see if you're right. Now run a frequency, report the result on this variable that actually measures happiness, relationship with partner. So go run a frequency and get the actual valid percents. Well, these are what they were. They have to be the valid percents because, again, valid percents does not pull in that missing data. So then you can say, okay, how close were your predictions? I allow you to do an open response for that one because I don't know what you predicted. And then if they differed for some reason, can you indicate other reasons that it might have been different. And so again, open response on this one. And this is just getting you to use data to make predictions, to start to wonder and hypothesize about things and do it out loud, because this is the kind of stuff you're going to be doing in your paper writing. What do these findings suggest about romantic relationships? And what I'm getting you to do here is discuss a couple ideas. You actually have to write a discussion section in your research paper. So this is just some mini practice at that. So this is you thinking something is a certain way, going into data, actually running a short, quick analysis to see what it actually is, if you're right, then unpacking what you found and discussing some of your ideas. That whole process is your research paper. And I even kind of brought your attention to it. Did you know you just made hypotheses, ran analysis, reported the result, discussed the implications? That's how we do stats and research. So I'm trying to get this pattern working inside your brain a little bit. Okay, so you start thinking about that stuff. And then kind of rounding out the lab, you actually had to run a little histogram chart, okay, and paste your chart in here. And I did a little video of how to do charts in the lab, I believe. So you kind of just drag your variable into the kind of chart you want to do. And you could actually plot it out just like that. I don't particularly love the graphing tool in SPSS. It's kind of clunky, but it does the job. It's okay. And you can change the colors and the title and stuff like that. Okay. Now let's test an idea about income and relationship happiness. So this is where we're actually coming up with a research topic. I think people with this kind of income tend to be happy or not happy, right? So we start making predictions. So again, open response on that one. You could pose this idea, and how does income impact relationship happiness, or how does relationship happiness impact income? You could actually go different ways with that. And then you had to say, okay, well, if I pose it this way, which one's the independent variable? If I pose it this way, which one's the dependent? Okay, so this is making sure you can recognize those independent and dependent variables. And again, just bring to your attention, do you see how switching these produces a totally different research question that involves different kinds of studies? So in the first part, how does income impact relationship happiness? We're thinking income is independent, or the predictor, and that the outcome, or the dependent variable, is how happy you are in your relationship. In the second one, in B, how does relationship happiness impact income? It's simply the opposite. We think how happy you are in your relationship is going to predict how much money you make. Okay, so you could pose this in different ways, and you actually get results in different ways. Now let's run a bivariate analysis to actually test your prediction. So we're going to run a chi-square cross tab of these variables. So we actually got variables for you that looked at relationship and household income. These are ones you used earlier in the lab. And then test the question posed in part A. And then I had you put kind of the rows and columns together. You had kind of these crazy little cross tabs that came out, and the chi-square test. And you were asked to paste it in and then interpret it. Okay. Chi-square tells us that this is not statistically significant. In other words, income does not have an association with relationship happiness. We had a little p-value of 0.842, which is right here. That's way too big for it to be statistically significant. So we say, you know, these two things aren't related, okay? And you could kind of open respond to your prediction, how it did, okay? Can you find other variables that you think might be relevant to predicting how happy people are? And there are 8,000 variables to choose from, so I let you kind of choose the 3 you wanted. And again, there's that last part on creating your own data. So this just prompts you through a few more of the steps that you're going to take for doing your own analyses and going about your own research topics. So I'm trying to build in these strategies and ways of thinking to make all of this easier for you. So hopefully you found this helpful, got some feedback on how you did. If you have questions, please let me know, and we'll see you next time.